Hey everyone, today we're going to be talking about the derivative of exponentials and logarithms. Now before we get into the video, I just want to say a couple of things. As always, if you aren't as comfortable with some of the topics we'll be going over in this video, be sure to check out some of the past videos in this series. And also, as you can see, this will be part one of a two-part mini-series within our Intro to Calculus series, where I'll be going over exponentials and logarithms and the derivatives of these functions. So be sure to stay tuned for the second part, which will be coming out very soon. All right, so let's start with talking about the derivative of e to the power of x. Now, if you don't know, e in math is actually a number, which is roughly equal to 2.718, and it's a very special number because it has a bunch of interesting and special properties, a couple of which we'll be going over in this video. So, since we're talking about the derivative, let's first establish a function. G of x is equal to e to the power of x. And then we're going to take the derivative. So we'll have g prime of x is equal to the limit as h goes to 0 of g of x plus h minus g of x, all divided by h. Then let's replace our g function with our e to the x function. So we'll have the limit as h goes to 0 of e to the x plus h minus e to the x, all divided by h. After this, let's separate our exponential. So we'll have the limit as h goes to 0 of e to the x times e to the h minus e to the x divided by h. Then let's take out an e to the x from this expression. So we'll have the limit as h goes to 0 of e to the x times e to the h minus 1, all divided by h. And then let's bring our e to the x away from our limit. So we'll have e to the x times the limit as h goes to 0 of e to the h minus 1, all divided by h. And this is okay to do because the e to the x that's to the left of our limit doesn't involve an h, so it's not going to be contingent on it. Now, we need to actually figure out what the limit as h goes to 0 of e to the h minus 1 all divided by h is actually equal to. Because if we were to input 0 for h, we would get an undefined value, which you guys can see in this graph here. But we're talking about the limit. We're talking about when h is equal to 0.000, a lot of zeros, 1, which means if you can see on the graph that little blue circle of 0, 1, that's where our value should be if there wasn't a hole in our graph. So saying that the limit as h goes to 0 of e to the h minus 1 over h is equal to 1 is okay to do because we're talking about limits and very small inputs of h. And this is unique to the number e, which is what I was talking about earlier about its special properties. So we can replace our limit with g prime of x is equal to e to the x times 1, which means that the derivative of e to the x is itself. And this is another special property of e. Many of the derivatives which we'll be talking about in the next video, in part 2, will also have derivatives being proportional to itself, but e to the x is the only function of the exponentials that's derivative is equal to itself. Now, let's shift gears here and talk about the derivative of the natural log of x. Now, if you don't know, the natural log of x is the inverse function of e to the x. And in terms of logarithms, the natural log of x is log base e of x. So, since we're talking about a derivative, let's first establish our function. F of x is equal to the natural log of x. Now from here, what I could do is talk about limits and try and describe the derivative like that, but I'm going to take a slightly different route and use the chain rule. So first, let's get x by itself. So we'll have x is equal to e to the power of f of x. From here, what you can see is that e to the power of f of x is a composite function. So we need to use the chain rule in order to take the derivative of that function. And the chain rule tells us that the derivative of a composite function, or j prime of x, is equal to g prime of f of x times f prime of x. So taking the derivative of both sides, we will have the derivative of x, which is just 1, is equal to the derivative of e to the power of f of x, which we know from before to be itself, because we have e to the power of some input. In this case, the input just happens to be another function, and then multiplied by the derivative of that input. In this case, that will be f prime of x. So altogether, we'll have 1 is equal to e to the f of x times f prime of x. From here, let's replace f of x with the original function. So we'll have 1 is equal to e to the power of the natural log of x times f prime of x. Now we can actually get rid of e to the power of the natural log of x because those are inverse functions, and that'll leave us with 1 is equal to x times f prime of x. And solving for f prime of x, we get that the derivative of the natural log of x is equal to 1 over x. Thank you guys for watching. I hope that this video was helpful and you got either a nice refresher about where the derivatives of e to the x and the natural log of x come from, or that you at least got to apply the chain rule in derivative problems. Be sure to comment down below what you want to see in future videos, and make sure to check out my channel because part 2 of this video will be coming up very soon. And until then, I'll see you in the next video.